Hello everyone, my name is Kushag Singh, and in this video I'll be demonstrating about the task which I was assigned for AI internship. Its objective was to develop a machine learning model that can detect flying birds in a video stream from the ground, and it should be able to classify the species as well, like egret, black kites, pigeon, crow, etc. When I was going through the task, I first searched about the dataset that I should use. Initially, I thought the best dataset I could get was Cub 200 because it had all the species which was mentioned in the email. Then I downloaded this dataset, which is of around more than 1 GB. The models I have used for training was ResNet model and MobileNet model. Why? Because both these models are following transfer learning, which makes it easier to customize their top level and train them on our own dataset, which makes the classification in images and videos much easier rather than using simple CNN or YOLO, and these are much better for the detection of particular species in our case. So, coming back to dataset, so when I train my model on this Curve 200, it the model's accuracy and the transparency of detection was very poor. It was not able to detect any species correctly. So that was pure due to the limitations of my computation power on my laptop because I was training only for 15 epochs and the one batch size of one epoch was around 200. So the computation power required to train on such a large data set was huge, and I don't have GPU on my laptop. So then I thought of selecting only few species on which I will train my model. So then I finalized these seven species of birds, and then I downloaded their dataset from iNaturalist, which was mentioned in the email. And initially, I downloaded 100 images for each of these species and divided them into the train and split 20 is to 80 ratio. 80 was for training and 20 was for testing. But then that was also poor in output. So then I increased the number of images in these. I then doubled it up to 200 images for per species from iNaturalist. Then after training my models again on the updated seven species dataset, my model was able to predict and classify the birds correctly on images and videos. So talking about few code files. This is the file responsible for managing the number of species and the dataset learnings. Then how are we calculating the risk exactly? So for risk, there can be multiple reasons though, but I have considered only these things. Altitude, if anyhow we can get the altitude, speed, behavior like are they flying, are they descending, are they sitting, and then the category. So based on these factors, I have set multiple threshold. Since in the videos or images, we don't actually get to know the altitude or speed of the bird. So I have used certain threshold. So what happens is if the uh, captured image gives a certain threshold more than the set threshold, it gives and classify them as small, medium, large, and what behavior are they doing. This is how my risk logic works. Then this train bird classifier is my main training file, which is responsible for training the iterative models on the dataset which I talked about earlier. Then test system is the file which I had created earlier to test my model output on the images and videos in terminal itself. Since building the app, I thought it will require more changes in the UI side. So I thought first testing it in the terminal would be a more quick method to test for my model's outcomes. I had created this test system file, which still runs and it still inputs the image file or video file and gives you the output and also the risk analysis. Then after getting satisfied with the results of test system, I then moved to making the Flask app. So this is the main Flask app backend file app.py, which also has multiple API endpoints. Say uh, I have one API point slash stream. Why stream? Because it requires the front end and back end to be connected with each other. So when the front end opens, I upload a video. The video should successfully get transferred till the back end and it should be accessible by the model. Now, when the streaming starts, the model's outcomes should also move to the front end to show the results and the visualizations which I have added in the app. So for that, we have another endpoint known as session summary. So that is why the multiple endpoints in this project I have used to contact between the front end and the back end of the app. And this is the CSS and a few functions so that the result and processing happens sequentially as required. So now let's see about the app. So yeah, why waitress? So we could have simply used Python space app.py, but since multiple times the frames get a bit laggy and there's a high throughput and a bottleneck like situation. So for that, for production grade scalability, I have used waitress serve. So now let's move on to our app. So this is the model selector I talked about, Ensemble, ResNet, and MobileNet. So Ensemble combines both of the best features of ResNet and MobileNet, and although it is slower than the single models, but it is more accurate since it combines the best features of both the models. But let's try MobileNet for now. And let's start with image. So for example, if I select this crows image, let's see. Yes, it classified it as crow. And here we can see the results: size large, confidence, behavior, perching, model single, risk is moderate. Now uh, let's see about a video. So this is an Egret video. I downloaded all these random videos from YouTube, so that is why they have these titles. uh, till the time it completes all the frames, let's see the backend and what's actually happening at the API point. So this is the console. Why there are so many console logs? Because while testing, I had multiple issues. So for that, I had added multiple console logs in the JS. Uh, so here we can see all the communications happening from front end to back end and uh, vice versa. I want to specifically see for the session summary. So yeah, so if we see inside the response of these API, so we get all the species which it has classified till this point, total detection, risk levels, and the medium, high, low of these. So this will take time because it has many frames. So let's stop it and see the visualization. So yeah, it recognizes till frame 86. Out of all these total detections, it is telling that most of the frames belongs to Egret. Model used was MobileNetV2, and this is the risk analysis graph showed here. Now let's see for some another um, let's see for this pigeon. So why did I use YOLO in this? So for YOLO also I tried multiple models. So one was YOLO V8N and the one which I'm using right now is YOLO V8X. So the difference between both the models was that one was more accurate, which is V8X, and it is a bit comparatively slower, but it helps me creating these bounding boxes more accurately near the object. By object I mean birds. So yeah, YOLO VTX is used in this project so that it successfully makes the bounding boxes near the objects, birds, and it helps the model to see at those points only instead of seeing here, here, or here. It tells the model that you have to see the image inside this bounding box and then do the detection and classification. So YOLO helps the models to basically classify the species of birds. Let's see what's happening in the backend. Okay, I see sufficient responses. So I'll stop this. So yes, here we can see that it classified this bird as pigeon 57 times out of 88, and this was the risk trend. And here we also have the bar chart for risk level, which shows it is low or high, so it is moderate here. Now let's see for Egret, let's say, and let's select mobile V2 Egret. Yeah. So I'll repeat again that these videos are downloaded from YouTube, random YouTube videos, so that is why they have these titles. And we can see the real-time predictions that the model is doing based on the frames, but until we reach a certain amount of frames to ensure that the model is predicting correct, we have to wait. So although it multiple times detects continuously wrong species, but at the end, most of the times it comes to a conclusion that this is the uh, mentioned species and it is correct. So like now it is continuously most of the time saying that it is a egret with high confidence. Let's see the number of detections. Although, by the way, we could have added these things in the front end also, but there was no need while the streaming was going on. So I have kept this in backend only, and I am not calling them in the front end. So yeah, total detections 54 and egret classified 23 times. So here also we can see that egret is being classified correctly most of the times. So let's stop this. So yeah, this is the species pie chart saying 32 times egret was uh, shown and detected. This is the risk level again based on the logic I discussed earlier that multiple times it showed based on the height, altitude, or being in the frame inside. So most of the times the risk moderate, although the risk factor is not that accurate and valid in this case because it depends on multiple cases and it can also be a critical risk and there can also be a collision probability or severity based on the weathers, based on the area on which the birds are flying. And it will also require multiple embedded systems or sensors to actually help the risk logic to work and actually tell what is the risk percentage of the birds flying in this area. But this is the very primary display of the risk logic of the flying birds in random sky videos. So this was all from my side, and the code is published on the GitHub. I have used CI/CD for developing this project, And I have also created a detailed README. And for more technical details, I have specially created this technical guide.md in which I have added most of the things. So this is the clear system architecture. Video input bird detector goes into the classifier, and then we get the risk assessment. And using the API endpoints, those are passed from backend to frontend and then to dashboard. So this was all from my side, and if you have any questions, I'll be happy to answer them. Thank you.